Hello there guys, welcome back to another epic inexorable maths video. In this one we're looking at a crazy looking summation. It's the sum from n equals 1 to infinity of arctan of 1 over n squared plus n plus 1. And we're actually going to use one of the compound angle formulas or the addition formulas for tan. It's tan of a minus b. We're going to use this result in a minute. So first of all, I'm interested in seeing if we can find the partial sum. So I don't want to go to infinity just yet. I'm going to focus on the sum from n equals 1 to, let's say, k of my arctan function. So the reason why I don't want to go to infinity yet is I don't want to deal with infinity. I just don't. We're going to use the method of differences. We're going to do a bit of stuff. I'd like to go up to k, and then what we will do is we'll take the limit as k goes to infinity. Okay, so k is just some whole number bigger than 1, of course. So what are we going to do? Well, we're going to do something a bit clever. Okay, we are going to use this formula, and we're going to use a and b to be very particular things. And this is normally, by the way, a trick that is actually used maybe more common than you would guess, where you've got arctan of something and you want to maybe see if you can write it as like arctan of something minus arctan of something, or maybe something like that. So you'll see what I'm getting at, you'll see what I'm saying, but let's go straight ahead. So what I'm going to do over here is I'm going to just label A to be arctan of n plus 1, okay? And I'm going to say that B is arctan of just n. So if I find tan of A minus B, so arctan of n plus 1 minus arctan of n, let's see what actually happens. So I'm going to be doing tan of A, so tan of arctan of n plus 1, that's just n plus 1. And then tan of B, B is arctan n, so minus just n, divided by 1 plus, again, tan of A, tan of arctan, that's n plus 1, multiplied by tan of B, and again, tan of arctan n, that's just n. So I get left with this, okay? So just humour me for a second, see where this is going. So I've got tan of my a minus b ends up being, obviously these n's cancel out, 1 over, and if I expand this out, I will have n squared plus n plus 1. And doesn't that look interesting? Because that is actually over here, 1 over n squared plus n plus 1. So all I have to do to get arctan of 1 over n squared plus n plus 1 is just take inverse tan or arctan on both sides of this. So this implies that a minus b is actually arctan of 1 over n squared plus n plus 1. And that's exactly what I've got. And what did I say a and b were? Arctan of n plus 1 and arctan of n. So basically, the long way around of what I'm trying to say, or I guess the short way around of what I'm trying to say, is that I can rewrite my arctan of 1 over n squared plus n plus 1 as arctan of n plus 1 minus arctan of n. And if you know anything about the method of differences, or also sometimes called telescoping series, you're going to have a big grin on your face, because you can see that if I start writing terms out of this, almost all of them are going to cancel out with each other, okay? And that's the beautiful thing about what we did over there. So if I actually just start writing some terms out, my first term is just going to be arctan of 2 minus arctan of 1. That's term number 1, okay? Term number 2 is going to be arctan of 3 minus arctan of 2. Term number 3 is going to be arctan of 4 minus arctan of 3, and so on and so forth, all the way up to my last term, which is going to be arctan of k plus 1 minus arctan of k. And you can see that everything's going to cancel out, or more or less everything. So I've got an arctan of 2 minus arctan of 1. Then I've got arctan of 3 minus arctan of 2. So the arctan of 2's cancel out. My arctan of 3 is later, we subtract 3 later on. Arctan of 4 is eventually going to get cancelled out with something over here. And basically everything is going to get cancelled out, including this minus arctan of k. That's going to get cancelled out with the previous term. We're going to see that there's nothing will cancel out with arctan of k plus 1, and there's nothing to cancel out with arctan of 1. So what we do get left over with, and of course the way that I've displayed it is not amazing for like showing the cancellations, but obviously try it yourself if you don't believe me. But what you will get left over with is minus arctan of 1. By the way, we know the value of arctan of 1. Arctan of 1 is pi over 4. And then we've got arctan of k plus 1. So overall, what we have is arctan of k plus 1 minus pi over 4. That's like our closed form answer. So if you want to go from n equals 1 to k, that's your answer. It's arctan of k plus 1, and that's it, we're done. If you do want to go to infinity, like in this question, you can now just take the limit, which we'll do now. So I've just condensed our result here so we can see this sum up to k terms is arctan of k plus 1 minus pi over 4. If we do want the sum from n equals 1 to infinity, though, of arctan 1 over n squared plus n plus 1, we can just take this limit. So this is going to be the limit as k goes to infinity of arctan of k plus 1 minus pi over 4. And of course, pi over 4 is a constant, so we don't really need to worry too much about that. And what happens as k goes to infinity to arctan of k plus 1? Well, you might know that as x goes to infinity, arctan x goes to pi over 2. No different with the k plus 1 and k. It makes no difference whether you've got an x or an x plus 1 here. So this is just going to be pi over 2. So it's pi over 2. And we've still got our minus pi over 4 there. That doesn't move or anything. And of course, our final answer is pi over 4. So that means that this sum goes to pi over 4, if you go to infinity, of course. If you want just the partial sum, it goes up to arctan of k plus 1 minus pi over 4. But I think that's a really cool question. It uses a lot of different areas of maths. You've got limits, you've got using the compound angle formulae, you've got summations, you've got the method of differences / telescoping series. So much going on. Hopefully you enjoyed the video, and I'll see you in the next one. Cheers.
With the song before number 3, and it's about me, so you better listen.